What is good, you guys? I am Jaideep and welcome back to yet another video of our channel. So before we start, I think I'm going to do this request at the start. If you're new to the channel and if you haven't subscribed already, do consider subscribing to this subscribe to the channel. And if you find the content useful, leave the feedback in the comment section and do share this video with your friends as well. As you can see from the slide, we're going to be looking at Jupyter Lab, which is basically the next generation of Jupyter notebooks. And to get started with Jupyter Lab, we are first going to look at the difference between Ipython and the normal version of the Python shell which we have. Then we'll move on to installing Jupyter. We'll go over a brief walkthrough of the UI, how Jupyter Lab looks like, how the notebook and everything looks like, what all menu items and options you have. Then we'll look at an important reason of using Ipython or Jupyter notebooks, which are the magic commands. And then we'll finish off with something interesting, which is Ipywidgets, which will basically help you to build interactive stuff within the notebook itself or Jupyter Lab itself. So with that being said, let's get started. Let us start with understanding the difference between Ipython and the normal Python shell, because Ipython is the basis of Jupyter Notebook. That's the kernel where Jupyter Notebook runs on. So what is the difference between Python, the regular Python shell, and Ipython shell? So Ipython has additional functionality, which not sure, I think functionality is the right word, but what it basically does is it gives you more flexibility or more commands. Commands is the auto completion. So for example, this is the normal Python shell firstly which I'm running. So if I try to do iter tools and just press tab here, it doesn't do anything. It doesn't complete, it doesn't give me iter tools. And also, one of the functionality which you might use frequently is the time it, where you test the performance of your code. So functionality like that, which is repeatedly used, you have to type it all over again, over and over again. Maybe you can wrap it around and use it maybe in a decorator or something like that, but you have to do it manually. So stuff like that, which is not available in the normal Python shell, that is available in the Ipython. So that's the difference between Python and Ipython. It's just a Python shell, but with some additional features which some people might find useful. So by some people, I think I mean obviously everyone uses it now, but the original developers did find some shortcomings with the normal Python shell, so they built their own version. To install Ipython, it's pretty simple. So what we're going to do is we're going to go to Miniconda, and I'm going to create a new environment. So conda create -n and -n, and what I'm going to name it is Jupyter Lab demo. Let's see if this creates an environment for me. I don't know the command for creating the environment, but I think this is worked. So nice. And conda activate Jupyter Lab. Oh, this, but I think Jupyter Lab. Find the it's demo. So if you're new to Miniconda, I do have a detailed tutorial for that on my channel as well. I'll leave a link to that in the description and the I button as well. So before you, if all these commands did seem a little bit alien to you, you don't use Conda for environment management, I think you can just check that video tutorial and come back to this one. Use Conda install Ipython, and now hopefully it'll try and install Ipython. So it needs some additional dependencies, and let's give it that. It is now installing Ipython, and if I now do conda list again, I think we have many packages along with Ipython, and this is the version. If I just start Ipython now, and Ipython has already started. So what I'll do is let me bring up the Python shell as well. Let me try to minimize this, and maybe. So if you see, the command prompt is also different. This has a nicely numbered and INC is input. So if I just do a is equal to 10, and okay, actually the first things from iter tools, it's already showing me auto completion. So this is one of the advantages of having using Ipython. It has this autocomplete functionality. It's very useful because we come from the world of IDEs. We have auto completion there, and I don't want to type everything. So from iter tools import, say I think pairwise. I'm not sure what the correct module is, but let's try. So pairwise, if you see, it gave me auto completion features. Along with that, I think along with that, we also saw the magic commands and all, which are basically not features of Jupyter Notebook as such. They come from the Ipython itself, but we'll look at them a little bit later. So this is the input. Say if I just do a equal to 10, and now if I try to print a, if you see output a is equal to 2, a is equal to 10. So this is the difference between Ipython and the normal version of Python. Basically it is kind of a supercharged version, and it has a lot of additional functionality. Want a detailed tutorial of Ipython itself? What I'll do is you can just request that in the description, and I'll 100% make that. So yeah, we'll not waste much more time going over the differences. You get the idea, right? That what is the difference between the regular Python shell and the Ipython shell. Okay, the next thing which we're going to look at is the difference between Jupyter Notebook and Jupyter Lab. So you might hear people use the word Jupyter Notebook a lot. Jupyter Lab is kind of finding its way into the mainstream, but if you see, the only thing which you need to know is Jupyter Lab is the next generation notebook interface. There's no other difference which you need to understand. So whatever I talk after this, with at least in this section, you can just skip that if you want. But the only thing which you need to understand or keep in mind is Jupyter Lab is just supercharged Jupyter Notebook. Now what I'm going to do is I'm at the home page of the Jupyter project. I'm going to give it a try, and I can try Jupyter Notebook and Jupyter Lab as well. So I'm not going to install Jupyter Notebook. What I'm going to do is we're going to try both of them in the browser itself, and just try to understand the differences. So Jupyter Lite is your notebook. Let's give it maybe a second or so to buffer up. And yeah, so this is the Jupyter Notebook, this is the Jupyter Lab. So if you see, the UI is pretty different. You have this left hand pane, you have these nice menu action item as well. There's multiple tab options as well, and there's an ability to select these consoles and all. But your Jupyter Notebook, I think it's pretty standard. It doesn't have any other. It has this menu, but it doesn't have this. So this is just like a single instance. This has much more features in it, and also it has this additional nice left hand pane. So kind of the difference between this is the only thing again worth remembering is Jupyter Lab is just the next version of Jupyter Notebooks. Nothing much to add here. Let us move on to installing Jupyter. Again, I've just clicked on the install part, and there's a couple of options. If you're using pip, you can install it using pip. And you can install Jupyter Lab, or you can choose to install Jupyter Notebook as well. So what I'm going to do is install Jupyter Lab, but instead of doing it from pip, I'm going to do it as I said, I'm using conda. So I'm going to do conda install Jupyter Lab. Was it? Let's try and check this. Yeah, it was Jupyter Lab. So I think I'm correct. I'm going to hit enter and hope this installs. I think I've got it right. It is kind of installing. Oh, it needs so many packages. Let's say yes. You can choose to install the Jupyter Notebook as well, but I don't think we are going to go there. We're going to concentrate more on Jupyter Lab for this tutorial. The installation seems done, and what we're now going to do is check the version. So what you can do is you can type in, firstly, I think, yeah, Jupyter -version, and if you give it a minute, if you see that the Ipython is already there. Ipywidgets is not installed, something which will install a bit later, or maybe we can install it right after this, and it shows the version of the Jupyter installations as well. So this is how we can verify your installation. And now that the installation is done, the next thing which I've done is I've created a folder within the F drive, which is Jupyter Lab demo, and that is where I've cd to. So we're going to start up Jupyter Lab in this particular location. We don't want to start it within the C drive. So what I'm going to do is how do you start it? It's pretty simple. Jupyter-lab. So this is the command which will help you start the Jupyter Lab. So we'll give it maybe 5 or 10 seconds, and Jupyter Lab should start up successfully in the browser of your choice. If you see, this left window is the one which I had already opened, and the right one, or this one, is the one which it is loading. So maybe give it maybe 5 to 10 seconds, and it will start booting up. And if you see, Jupyter Lab has already booted up for us. And this is the same UI which we saw a couple of minutes on the online version, and it's not much different. So this is the folder which we have. So this is from the F drive. This is the running kernels and all. We'll talk about this layout in a bit. Okay, I think now that we are at the UI, I think something which I should have already talked about. Where does this name Jupyter come from? It comes from the languages it used to support. So I think the language was Julia, Python, and R. So that's where the name Jupyter came from. I think I don't know if it makes sense, but let me open the text file and see if actually. So Jupyter. So this is from Julia, this is from Python, and this is from, I think this is from R. This is from R. So something like this. So this is where the name came from. Okay, not deviating from the topic, let me discard this. I don't want to save it. Actually, if you see on the left hand side, it's already saved it. But let's go over the menu. So the file is pretty so this particular menu on the top is pretty standard to everything else which you would see on any other application which you start up. So if you want to, the main thing which you want to which we are concerned about here is the save and export. So if you want to save and export what do you say? If you want to save and export the notebook or the ipynb file, and then this is where you can do it from. And if you see, it supports a number of formats. You can export it as PDF, HTML, ASCII doc, RST file, stuff like that. Edit and view it, I don't think that's much preferred. This is just to kind of enhance or change how this UI looks to you. Run is something which is important, but we'll come back to that when we're running this. Basically, to run the commands and run the cells, that is where this comes into picture. So the kernel is the one which is currently running. So we are running Python, but as I mentioned, Jupyter Lab not only supports Python now, it supports many languages, and that's where this kernel comes into picture. Tabs and settings, I don't think the theme, maybe if you're interested you can just change it, but most of the other most of the other stuff is pretty standard. On the left hand side, what we have here is this is obviously, you can create folder, current location and stuff like that. The one thing which is of interest here is the extension manager. So we'll talk about this. I've already enabled it. What I can do is maybe I can disable the extension manager, and if I go here, so the extension manager is gone, and if I enable extension manager, and it will ask me whether you want to kind of enable extension manager, then we can do that as well. So we'll talk about the extension manager towards the end of this video, which you already see here, whether you can start a notebook, you can start the Ipython kernel. So if I just start the Ipython kernel first, so if you see, the kernel is already started, and this is the kernel is actually the Ipython console rather is already running. And if I just do a is equal to 10 and shift enter, then if you see the one which we saw before, it's just pretty much the same. And if I now do, or if I just do and run this, so it will print the output as well. So this is pretty much the same. This is the Ipython console which will start up. Now next we'll start the notebook, and if you see, the extension is .ipny. This is Ipython notebook, and this is the extension of all the files, and they're not currently named. What I can do is I can just save notebook, and I'll give it my first notebook and save. Now if we open the browser, if you see that the my first notebook is present here. So basically where we are saving this, the path is here, Python Jupyter Lab. So that's where we are saving everything to. Now let us look at what is happening here. So the commands which are available as part of kernel and run, they are available here as well. So this is obviously save, this is insert a cell below. So everything here is a cell. Here you can type your inputs, and if I just do a is equal to 10, and if I type in a, and let's try to run this. So if you see, this is already, you don't even have to type print. This already understands that this is you have to print this, and this is, so this is the input cell and this is the output. If we do a more complicated one, I think if I do a is equal to hello Jupyter, and if I just do this, then if you see, that selected cell was run. If you want to run all of these cells together, I think you can go here and run all cells. You'll run the all cells. You can go to kernel, restart and clear restart kernel and clear outputs. So it will reset these cells, and what you can do is run all cells, and if you see, it has run all the cells. Similarly, I can stop the kernel or interrupt the kernel. This is just the run command. And so this is about pretty much about the initial impressions of the UI. This is how you can use it. Points worth remembering: this is the cell, this is the output, and the output is inline. Before moving on, I think the last topic is, if you remain interested in what all kernels it supports, this is the link, GitHub Jupyter. It's hosted on GitHub. I'll leave this link in the description as well. But this is basically all the kernels which it supports, how to install them. What I've done here is I've written a function which is named complicated, but it's not. If you are aware with Python, this is just a logic to separate the code. So what I wanted to show actually is, let me restart this kernel. So kernel, restart kernel and clear all outputs. And on the top right, you can see the kernel which is running, and you can also see the debugger. So now that if you just click this small circle icon here, it will show the status of the kernel. It's ready or it's idle and stuff like that. So if I just and what I can also do here is click this small bug and enable the debugger. So on the right hand side you'll see the debugger, and here also you'll see the option to set breakpoints. So to do debugging here, it's pretty simple. You set a breakpoint here, I think, just some sample purposes. And what I can now do is run this cell, and if you see, it's stopped at the first breakpoint. It's showing the values of the variables as well. And this again is pretty simple. You can just move on to the next line. It will show where it is. It's not the most kind of the most intuitive way of working, but this debugger is already available, and you can just do this and you can get an idea of what is happening in your code. So the debugger is also available. If you just stop this debugger and go to view and view, so this is the right hand side bar, and I can close this. And similarly, if you go to the view and show left hand bar, this will go as well, and you have a bigger working area. So again, to play around with this a little bit, if you see here on this top menu, it has code, markdown and raw. So as you might have already guessed, markdown is also supported. So if I do something like this, and this is a heading, and if I run this, this becomes markdown and this becomes the heading. Similarly, I think other commands are also available. So if I just do something like go to Google, not Google but Google, and www.google.com, and if I just do this, I think there's some issue with this maybe. Okay, I think I've selected as code. I need to make it as markdown, and if I just press enter and just click this, a bit about the support for markdown. I'll not go into detail because the commands, I think the markdown commands are pretty much same everywhere. You can just do a simple Google search, and all the commands which this particular markdown supports, there's a nice cheat sheet as well. I'll leave a link to that in the description as well. Zoom in a little bit for this one. What I can also do is if I put an exclamation mark, and I can then give Unix or based on the OS which you're running. So I'm running on a Windows OS, any commands which are available. For example, if I just do a dir and run this, it'll show me the directory structure as well. So as I mentioned earlier, I've started this on Python Jupyter Lab, so these commands are available as well. I think any other commands, maybe pwd, I'm not sure if this supports, but yeah, pwd is not recognized. But any of the Windows based commands or the OS specific commands, to be more precise, you can just put exclamation, and this will help you run the OS based commands as well. We are almost towards the end of this tutorial. The two important points which we're missing is the study of magic commands, and this is the most important part which is available as part of Ipython and Jupyter Notebook. So what do magic commands essentially do is all the repetitive functionality which we might think of, that is bundled together in easy single line commands or in a single word commands. Now to display all the magic commands, what you can do is %ls magic, and if I run this now, it will show me all the line and the cell based commands. Now what is the difference between line and cell? So the line commands work on a single line, the cell commands work on the entire cell. So if, for example, this particular cell has only one line, then the line magic command will apply. But if you have a long code which spans over 2, 3, 4, 5, 6 lines, or if this cell has, say, maybe a function which we wrote something like this, maybe if this cell has more than one line, then if you want to perform some magic commands over this, you have to use the cell magic commands. So that is the difference between line and cell magic commands. Now the list of this is endless. Covering all of them might not be possible, and this is the cell magic commands. I think I'll go and minimize this, and I have two resources for you which will help you learn these commands a bit better than me explaining all of them. The first one obviously comes from this tutorial point, and second is the official Ipython documentation. Now some of the commands which you might want which you might use frequently are, I think, something called as %time. Yeah, %time. So if you want to get the execution of a execution of a code, what you can do is %time and test the execution. So what you can do is, let's paste this command and run this. So the %time will show you the wall time. So basically the clock which basically the time on the clock. So what I can do is I just give this something else. So it's now calculating. I think I should have done something smaller, but yeah, let's see how it goes. And if you see here, the kernel is busy, so it's trying to calculate this. Let's see how much time it takes, and clear output. And let me try this now. I think it's still hanging, but I think that's what you get. Okay. So it still took a small number of seconds, but I think a better example would be some range of, say, 10, and this one. and if I do this, so it took 144 milliseconds to run by the wall clock. So this is using percent time, but if you do percent time it, then it will give you the speed of execution or the performance of this. So that is the percent time and the percent time it command. Now there are other interesting commands as well. So if I just go back to the documentation, I think what we can do is, so I think we'll look over one more. So if I create a kind of .py file here, so let me create one. I think what I'll do is go to maybe not console, but let's try to open a new file and Python file. And what I'll do is I'll take this example and I'll put it in a Python file here, and I'll save this. Maybe I think rename Python file sample.py. Now if you want to load this Python file in this particular cell, what you can do is you can use the magic command run, and the file is sample.py, I think, and let's try this. Hopefully it works, but because it doesn't, okay, I think because it doesn't return anything, let's do this and let me try to run it again. So if you see, this has this has been loaded, this has been run from the sample file. Similarly, if you don't want to run this, what you can do is you can simply load it using load sample.py, and if I run this now, it's just loaded the entire code in this cell. So these are kind of the magic command. Some other commands which are there, I think we can try percent p info. I think so what we can do actually here is, if I just do, I'm going to try this. So a followed with a question mark, or is equal to 10, and if so this a question mark, this actually comes from Ipython, and what it tries to give is a description of this a variable. Now instead of doing that, what you can also do is percent p info a, and let's see, this also gives the same thing. So instead of having a question mark, what you can do is this percent p info. The other thing, or the other magic command which you might want to do is maybe percent write file. I think this is something which you can do, and if you want to write an output to say, what you can do is write to sample.py, and what you can do is run this. If you see, write into sample file, and if you see, the write to sample file is present here as well. So you can use multiple commands like this. I think what we're going to look at next is something which is called as Ipywidgets. Now what it does is, it's a library which helps us build interactive widgets. So let's go back to Conda a bit, and let me close this. Actually let me close this session. I think I should have opened a new mini Conda prompt, but let me close this session and let me do a Conda list. Actually not even Conda list. What I can do is Jupyter -version. So Ipywidgets here, if you see, it's not installed. So what I'm going to do is conda install Ipywidgets. So because we have installed a library, what I'm going to do is I'm going to try and copy paste the code now, and also I think, yeah, what I've done is I've downloaded a library from Kaggle which is called the FIFA 22 data library. So if you haven't watched previous videos, I do like football, and what I've done is I've downloaded the data sets from Kaggle. It's free, and I'll leave a link to the dataset in the description, and we're going to use this we're going to use this dataset. Firstly, what we're going to do is we're going to import the necessary libraries, Ipywidgets, and I think import pandas as pd. So this works as well, and what we're now going to do is pandas is not found, which is interesting because it should have added, and I think it's not working. So strangely not working. What I'm going to do is I'm going to close this and come back. So leave this and close this session as well, and let me try to restart Jupyter Lab. Yeah, I think there was some issue with the sync up of the restart. So I've done this now, and I think I can import pandas. So what we're going to do, what we're going to do first is try to read the data frame. So data is equal to, and as I mentioned, what I'm going to use as data is just the files which are available here, and it is nothing but a Kaggle data set of players. And what we're going to do is players22.csv. I think this is okay. So pd.read, and if I just press tab, it will give me all the autocomplete features as well, which is pretty nice. So I think it's layers underscore 22 csv, and let me try to let's write data dot head. This is this low on memory false. I think let's not do this. Let's display the first 10 records because it has it's a bigger data set. So columns to have mixed type. This specify data type on this. I think this is okay as long as we can see the data set. Let me close this one. Let's ignore the errors for now. So what I have here is a practice data set, and what we're going to do is try to build an interactive widget. So building an interactive widget is pretty easy. I think what we're going to do is we're going to try and take and filter players based on this overall or any numeric value, overall or potential. So we're going to build an widget, and for that what we're going to do is from Ipywidgets we're going to import something called as interact. So this is a decorator. So at interact, so this is the decorator which we're going to use, and def filter underscore players underscore by data. I think not the best name, but this. And the arguments which we are going to give to this is filter by is equal to this filter by we're going to give a default value. So maybe default value as potential. So this is the default column which you're going to fill, and let's take players which have rating above say 80, and then what you're going to do is return data dot location and data of filter by greater than x. So what this is basically trying to do is trying to filter this data set by this particular column where the value is greater than this particular value. The default value of the filter by column is potential, and the default comparison value is 80. So let's try to run this, and if you see this filter by column is available, and only players with potential above 80 are available. Now I think there's a lot of players who are above 80. So what we can do is we can try to let's try to simplify this. So if you see above 100 there's nothing. Maybe how about 87 or maybe 92 or 95. So there's only few players left. There's only 5 players who are above that. Messi, there's no Ronaldo here, sadly. Let's see why there's no Ronaldo. Oh, he's 91. So I think that's. Now if you want to change the column, what you can also do is overall, and that should work as well. So people above overall 99, there's no one. 92, if you see there's one player above 92, that's Lionel Messi, and stuff like that. So this is how you can build interactive widgets. So this works for everything. I think I just showed you one example how you can do that, but there's a lot to play around. So for example, right, so there's much more you can do. I think again on the tutorials point there is a nice description of how you can build say a simple calculator, or not a calculator but how to add numbers and all. So a lot can be done using this Ipywidgets module. I think it's you are free to explore that as well. But an interesting use case which I showed you, I think this is pretty nice, that you can build actually this filtering. And this not only works for a kind of data, but if you plot the data and you want to filter based on that, and that works as well. Plotting using Matplotlib is also pretty easy when you're using this Jupyter notebook interface. And firstly you have to install Matplotlib, obviously, because we're using Miniconda and it doesn't have it. So we're going to install Matplotlib first, give it a minute, and then restart Jupyter Lab. So post the installation, I'll see you post the installation. Okay, the installation is done. Now we're going to restart Jupyter Lab. And maybe give it a minute. Jupyter Lab is now restarting. So what we're going to see is how we can bar graphs. I think using, obviously you can use Matplotlib to plot a number of graphs, but what we're going to do is for this this demo purpose, what we're going to do is how to plot a bar graph using Matplotlib. So to kind of plot that, what you're going to do is we're going to use this PL points 2022-23 dataset. So this is something which I've prepared, and this is nothing but a Premier League table. So if you're from the football world, this is the current standing and how the teams are positioned. So what we're going to try to do is plot this chart of teams based on the number of points. So that's what we're going to attempt. Import pandas as PD, import numpy as np, and import matplotlib I think matplotlib dot pyplot as plt. So this is pretty much it. And nextly, what we're going to do is use another magic command, matplotlib inline. Let's run this and see if it is okay, if it has any problems importing. So this kernel is busy, I think it's executed, and let us now try to read this file. So data is equal to pd dot read, again csv, and the file is named pl underscore points underscore 22 underscore 23 dot csv, and data dot head, maybe the first lines. Yeah, I think this is okay. And if you want to see the shape of data, you can obviously do data dot shape. I think this also works. It has 20 rows and 6 columns. So we know the data frame is good. Now we're going to try and plot it in a graph. So what we're going to, okay, now that the data is good, let us try to plot this. And we're going to plot the bar graph. And as I said, just open the data once more. And what I'm going to do is I'm going to rename this notebook as well. Rename notebook to plotting, demo plotting. I think that's a good name, and rename. So just to recap, what we are going to plot is these teams and the number of points they have. So Arsenal has 15 points, City have 14, Spurs have 14, and so on and so forth. So the graphs should represent the number of points. So that's what we're going to do. And so for that, what we can do is plt dot bar, because we want to do bar graph. And what we can then do is on the x-axis is equal to np dot arrange 1 to 21, and what we want to arrange is let's give height is equal to data and points, because that is the name of the column. And let's try, I think that for now is sufficient. So let me try to run this. So if you see, the bar is already plotted. We don't have any meaningful labels or on the x or y axis as such, and also we have these integer, not the integer but floating point numbers on the x axis. So time to change that. Also we have this bar container, which is basically an object, and you can make it go away by simply saying dot show. And let's try to run this. So at least the container representation is gone. Now I think what we can do is we'll just try to label the names. So we know that these are points of certain teams, but we don't know what teams they are. So let's try to label them as well. So plt dot xsticks, I think plt dot, I think not xsticks but x label teams, and plt dot y label points. And let's do this now. So yeah, these are points and these are teams. Again, I think the teams don't show much, and also this graph doesn't have a title. So plt dot title Premier League standings after 6 games. So Arsenal are top of the 6 games, not the biggest achievement, but yeah. And what we want to do is we also want to give each graphs the name of the team. So what we can do is plt dot xsticks, and again I think the same thing, np dot arrange, and from data I think the column is team and not teams, so let's do that. And close this, and rotation is equal to 90, so that it's properly displayed. Now let's run this one more time. And if you see, the team names are also available. I think we can just remove the external then. And this is now available. One more, so this is how easy plotting is using Jupyter Notebook. If you go and do this, let me just minimize this. I think if you go and do this in a different ID, I don't think it will be that intuitive to look at, or that nice to look at for that matter. I know there are certain IDs are coming up with Jupyter Notebook support, but I think if you are more interested in the data side of things, visualization, AI, ML, I think this is your go-to tool. I think the last thing which you can do is give these teams a distinct color. So we have 20, and I know from following these teams that they have certain colors. So what you can do is, I'm going to use the shorthand notation. So R is red, so Arsenal are red, City are blue, similarly Spurs are maybe white. And what you can do is, in this bar, what you can do is color is equal to team colors. And let's try to run this one more time. If you see, all the alternate bars are of different colors. Now let's try to add some more. But what you can do is, who are the next team? Brighton are pretty high up in the table. So Brighton, and I think they're United or red. Let's see this now. If it's more readable, I still think not. Maybe what you can do is, instead of this white, what you can have is green and yellow. I think the graph is pretty much more readable. So I'm not going for all the team colors, but yeah, the graph is pretty much pretty more readable than what it was before. So this is how you can use Matplotlib within the Jupyter Notebook. This is all about Jupyter Lab. I hope I was able to give you an idea about how to install Jupyter Lab, how to use it, what all these menus contain, and what is the advantage of this Jupyter Lab, the next generation interface over the traditional Jupyter Notebook. Just worth pointing out, this project Jupyter is no longer limited to 2 or 3 languages. It supports a lot of them. And some important stuff, what are the USPs or unique selling points? I think the ability to run everything inline. This is called as a cell block. I think you can run all of these cells together, and it does support a lot many languages than just Python. But yeah, if you're from the data side of things, you can see that this is already a very good tool to use instead of the other IDEs such as PyCharm or VS Code or any other tool for that matter. I think there's a Google Colab tool as well, which is online. Also, if you want to try out Jupyter, you don't have to install it. You can try it online as well. So that is all about Jupyter Lab.